So going back, so greater than or equal to signs, we can do this by simply typing things. For instance, if I want to see if I have a equals 3 again and b equals 5, and I want to see if a is greater than or equal to b, I simply type it like this, and then if it is, I say print high as a result, and you can see it did print high because b is in fact greater than or equal to 3. Okay, so those are some basic operators that are used, math and logical operators as they're called. We'll be looking at others throughout the course. Another one that's important is membership and identity operators. This is the key terms in, not in, is, and is not. We don't have to necessarily use is and is not. Those are less important, but the in and not in, particularly the in, is very important, and it's going to be used a lot for things like loops. So if you remember, we had things for things like lists before. So let's say A is a list where it has values 1, 2, 3, 4, 5. Okay, so it has 5 values. So if I want to get to those values in a kind of loop, we'll talk about loops in a moment. Loops are basically a quick way to go or iterate through the values in a list. So one type of loop is called a for loop. So if I want to get the actual value in a loop, what I do is type for, which defines a for loop. I is a variable, just a variable I've created, any variable, and it will refer to a specific variable within the array or the list called A. And then in is referring to the membership of that I in the array. So if I is just a variable in the array, in is referring to that array. And so I will say I in A. So for I in A. And then what I want is to do is print the value of A. So what I do is simply get print A, and then I say give me I from A. So what's happening here is basically, I'll press return. So it went out of index bounds adder, which is fine. I mean, there's more than, I'll explain that in a moment. But so basically what's happening is I define A as a list, as you can see here in this line. Okay, so the for loop tells it to loop over the A list. I is in reference to a value that will be from here. It's just a variable I've created as a name. In is telling that I should belong to A, and then A, of course, is the actual list. So what it's telling it is that I'm telling it to print the value I from A, and you can see it prints that value. Now, the reason why it has this error towards the end, because it says when it gets to 5, it's telling to get the 5th member from A. So I is the actual number in this case. So what I'm telling it to do is print 5, the 5th value from the array. Now there's actually, so remember, we start counting at 0. So if I'm getting number 5, it's actually the 6th member, right? So A0 would be the first member, so it would result as 1. A number 2 would actually be the 3rd value in this case, whereas A5 is actually the 6th value, and since there's no 6th value, we get an error towards the end. So if I defined it as A equals 0, 1, 2, 3, 4, 5, then this time we should have hopefully less of a problem for I in A. Okay, and then print A, I. Okay, and you can see this time we didn't have any errors because we started counting from 0. Now there's cleaner ways to loop through these kinds of things, and I'll show you that in a moment. But that's one way you can do this, is basically is just get through or get through the list values by simply starting at the 0 count and then getting that value. So you might want to reference lists differently. But in this case, what we're trying to demonstrate is basically use the in keyword as a way to reference values within a list. So where I, in this case, is a member of that list, and A is the actual list, and in is telling I is a member of list A. Okay, so that's basically what the I does. And we could simply change it to not in to say if you're not trying to get a member from that list. To be honest, I never almost ever use not in, so I won't use it too much here. Is another way to see if something is partly or equal to something. Evaluates true if the variable on either side of the operator point to the same object. It's basically an double equals sign, if you think of it. So because we have double equals, we don't necessarily need to use is, and is not is the same as not equal to, which we've already demonstrated. So essentially this, so A equals B, double equals sign is the same as be false. So you see false. So remember we defined A equals 3 previously and B equals 5. So is the same as basically this. So A is B, and you can see it's false. So essentially is the same as double equals to, and is not is the same as this basically. So it's true, and then here is not, and that's true. So you can see these things are the same. Okay. Now another very important concept is the if and else statements. If and else statements allow you to create logic within your programs, essentially, and that's going to be important for many, many things. So the structure is quite simple. The first sort of conditional is always the if. So if A equals B, so if you remember we did that, then print high. So you can see it shouldn't print high because remember we defined A not to equal B, so it didn't do that. But what if we did this? A equals B, print high, else print did high. So again, it isn't printed. But if we did else if, so if we did else instead, oh, we have to indent, sorry. This is a problem with this. Print high. No, it doesn't like my syntax.